All right, so to review for chapter 6, in 6.1, we were exploring graphs of polynomial functions. So what is a polynomial function? Well, a polynomial function contains operations of multiplication and addition with real number coefficients. So here's a coefficient. Okay, whole number exponents. There's an exponent, only whole numbers. Okay, no negatives, no fractions or decimals. And in two variables at maximum. So we have x and we have y here. Sometimes you'll see it in function notation. Okay, that's the same as y. So polynomials, you're adding or subtracting terms. Okay, most of the stuff we've done is most of the equations are polynomials. All right. So and here's a bunch of examples here. Here's some non-examples, right, of non-polynomials: square root of x, x to the 1/2, x to the negative, and so on. Okay, we talked about degrees of a function. So the degree of a function is the largest exponent on the x. Okay, the largest exponent here. So we have x squared, that's degree 2. X to the 4th, we have degree 4. If we have multiple terms like this one down here, okay, we have x cubed is the largest exponent on the x term. And so that one, that one is degree 3. End behavior for a basic linear polynomial function, linear, that's a straight line, is going to go from 3 to 1 or 2 to 4. Okay, so if the slope is positive, like this one, goes up from left to right, then you've got end behavior of 3 to 1. If the slope is negative, like this, negative 2, then the end behavior is 2 to 4. Okay, quadrants, starting at 1 here in the positive x, positive y is 1, then goes 2, 3, 4 counterclockwise. 1, 2, 3, 4. All right, in talking about functions, turning points are where the function is decreasing and then turns to increasing. So at that point, that's called a turning point. And here is a turning point for this graph right here, this point right here. And here's another turning point right here. So cubic functions are functions with degree 3, functions of degree 3, and they can have a maximum of 2 turning points. Now you could have a polynomial function that looks kind of like this that really has no turning points. This one doesn't behave quite like this one. So it could have 0 turning points, or it could have 2 turning points, that kind of thing. All right. A constant function is just a straight horizontal line, like y equals, some number, like this one would be 1, 2, 3, 4, y equals 4, or y equals negative 4. That's a constant function. A linear function would be degree 1, and it's a straight line, either going up and up or going down, like this, positive slope, negative slope. A quadratic is degree 2, so that's like your y equals x squared, or your quadratic functions. And cubic functions are degree 3. And I'll let you study this chart for x-intercepts, y-intercepts, and all that sort of stuff. You'll have to take a closer look at that, perhaps in your study tonight at 6.1. Okay, 6.2, we talked about characteristics of equations of polynomial functions. So what are the equations? What can we get from looking at the equations only? Well, what we can get, y equals ax plus b, is similar to y equals mx plus b for a linear function. And we can get from this that the number in front of the x, or multiplied by the x, is the slope of the line. And the constant is the y-intercept of the line, where it intercepts the y-axis here. So that's what we know about a and b. What do we know in a quadratic? Well, a tells us if the number itself is greater than 1, then that is a parabola that opens up very narrow, like this, okay? It's very, very narrow. If a is between 0 and 1, we know that it's a very wide parabola function. If a is negative, it opens down. If a is positive, it opens up. So we know that. B doesn't really tell us a whole lot. It tells us something, but we don't really concern ourselves with that too much. We focus on C, though, the constant. Again, that's the y-intercept. So wherever the parabola intercepts the y-axis is going to be at this number, whatever that is. And cubic, of course, very similar. If a is positive, it goes from quadrant 3 to quadrant 1. And if A is negative, it goes from quadrant 2 to 4. So it kind of slides up or slides down. And then D, of course, again, y-intercept. So those are some main characteristics of equations of those polynomial functions. The leading term would be the A value, or the constant that's, the multiplier, the number that multiplies by the term that carries the degree of the function. So in a quadratic, this is the leading term right here. This is the leading coefficient. In a cubic, this is the leading term, and A is the leading coefficient here. All right. We went over this chart too in our notes. So we just summarized what A does for each of those. We made some connections here. Obviously, this shape right here is a cubic function, and so is this shape, cubic. This is a parabola right here, that's quadratic, and linear is a linear function, degree 1. So we did some matching there as well. The constant term, the one with no variable, is the y-intercept value for all of these. And that was pretty much 6.2. Okay. 6.3, we started talking about lines of best fit. So to draw a scatter plot would be, if you have an x column and a y column like this, the point 1, 1 would be a point over 1, up 1. That's this red one. The point 2, 4, over 2, up 4, over 10, up 12, over 16, up 20. And if you plot all those points, you get the red points on the graph here, right? Now the line of best fit would be sort of like the line that best approximates the general trend of the dots. So without this line here, you can kind of see that these dots kind of rise fairly evenly. Not exactly evenly, but they kind of rise fairly evenly. And so you kind of have this thing happening right here where you can see, that's the general trend where my cursor is, like right there. And so you would draw a line that would travel right through the middle of the collection of points there, if it generally kind of forms a straight relationship. And so remember, the line does not have to go through all the points. It does not even have to go through the first and last point. This one happens to. But what you want to do is you want to make sure that that the line kind of travels, that there's an equal number of points above the line as below the line. And I think at one point I adjusted this this line. Let me just see here. I would actually have that line maybe, come on, move for me. So maybe even there would be better. So I have, 1, 2, 3 points above, 1, 2, 3 points below. That's a great line of best fit right there. Okay? So notes on that. If we're trying to find information from the line of best fit inside where the collection of points are on the graph, that's called interpolation. So I'm getting a data point that's, say, about here. Extrapolation is where I extend this line past where my data points are, and I would get a value on the line that's definitely beyond or extra, in the extra time area there, okay, outside of where the points are. The equation of the line of best fit. We spent some time determining the equation. So you've got your points, you draw a line through the middle of the collection of points, and then what you do is you find the slope of the line, taking change in y over change in x between 2 points that are on the line, and that's your slope. And then find out where your line crosses the y-axis, and that's your intercept. Here's your slope right here. This is a -1 slope. And here's our intercept, positive 7.7. That's what it looks like there. And so that's our equation for this line of best fit. Really easy. Just throw your hand up if you have any questions, or bust in if you have any questions, okay? No problem if you do that. This is where we first learned about getting the graphing calculator to do regression functions, right? So we've spent a lot of time on that in chapters, I think in all the chapters, 6, 7, and 8. So this is a huge part of this unit. There's your stat lists, okay? You can calculate a line of regression right here, number 4. Or we can do any sorts of shape of graph of regression. So I won't go over that in this little review, but you can certainly, there's lots of videos on using your graphing technology to find lines of regression. And I think what we did was we found the exact line of regression here, and we had much the same, this is what the calculator said, that line of best fit would be for that last example. And we had -1 plus 7.7. So we were super close on our estimation. Okay, so regression lines, and here's some questions, and you can look up some videos and homework questions on that stuff if you want to review that some more. Is there a question? Hand over there? No? Okay. Curves of best fit. I think this is nearing the end of the chapter. A line of best fit right here. If you have the points that clearly form somewhat of a straight line, you can do a line of best fit. If you have points that are in a bit of a different shape, like maybe that's a parabolic shape, well, then you have a quadratic curve of best fit. And if you have points that look like, hey, you know what, that's neither of these first two. It's not really straight, it's not really quadratic, but that would be a very good cubic kind of shape. And then you could do a cubic regression line or curve of best fit. And of course, we plotted this and we, blah, blah, blah. But we also got the calculator to do that for us, right? We found some quadratic and cubic curves of regression with our calculator. So you have to remember how to do that. We also talked about how to find x-intercepts with the calculator, right? Left boundary, right boundary, guess. Talked about a little bit about that. We also talked about maximum and minimums, how to find a max and min. It's all on this menu here when you go to second function, calculate. Second function, trace button. There you've got your 0, that's x-intercepts. Minimum, maximum, there you go, intersect between two lines. Those are the ones you use a lot. And again, there's different videos and stuff you can go back and watch if you need that. Quadratic regression, okay, that's a quadratic, and the calculator can determine these values for you if you put in the points in the stat lists. Okay, but you know that pretty well, I think. Okay, so that's it for the review for chapter 6. If you go to my website, mrmathwellcom, you can see that you have here's all the videos and different things right here. Your homework that I've given you. But here's your videos and your homework questions. Some files there with steps for regression and so on. And I have a chapter 5-6 review video. I'm going to be putting this video on there as well if you want to look at just the chapter 6 video. Do you have any questions for me, or was there anything from chapter 6 that you think I missed you'd like me to refresh you on? Okay, so take a look at your textbook, read your textbook. I don't have any chapter 6 sections up here, but take a look at your textbook, read those in summary key ideas. Those are really good. And go to mrmathwell.com.